Hi, I'm DJ Ware. On this episode of the Cyber Gizmo, this is part 2 of MirageOS. We're going to be talking a little bit about the Unikernel software, and then we'll go through and set up an environment and run through a couple of examples. As we said last time, if you missed that, I'll put a card up here to allow you to go back and watch the first video. But MirageOS is a library operating system that constructs unikernels for secure high-performance network applications across a variety of cloud computing and mobile platforms. So if you want to know more about what the heck a unikernel is, watch the first video. How does it work? So MirageOS treats the Zen hypervisor as a stable hardware platform. So we can then focus on worrying about high-performance protocol implementations of whatever it is we're trying to build as a service. So why would you use the hypervisor as an operating system? Well, the big problem that you have is that since I have to create an operating environment of some kind in the unikernel for every app that I generate, do I really want to stack 1,000 different device drivers into each one of them? No, I don't want to do that. So they're using the hypervisor in order to handle all that extraneous code without having to put it in every application. That allows a secondary efficiency step that allows me to only include the device drivers that particular unikernel needs in order to execute without having to bring them all into the application space itself. Your hypervisor operating system is protected from the app, and it is in a secured space, not just being completely secured, but also it's not very easy other than through the APIs to be able to get there. Now, I want to tell you, there is a secondary project that's going on that a bunch of guys have been working on in order to speed up the interfaces between the unikernel and Zen. And so they have been looking at, okay, so what's the best way to do this? It isn't just a stock, use the hypervisor API. They're going beyond that. So code is developed in a high-level functional programming language called OCaml. So you can develop on Linux or Mac OS. There are extensions in MirageOS for 50-plus libraries. Those map directly to the operating system construct. So, yeah, I mean, they are picking them up, and some of those they're picking up are TCP/IP, DNS, SSH, OpenFlow, which is a switch and controller interface, HTTP, XMPP, which is a messaging protocol, and Zen inter VM transport, so you can talk to other VMs as well as being able to launch other VMs. One of the things about Mirage versus our traditional environments, I mean, before we talk about the Raspberry Pi, one of the advantages to the MirageOS is that if I'm in a scale-up environment where I need additional VMs to be able to handle a workload, they spin up within milliseconds or even nanoseconds in some cases, depends on how well you write your code. But you cannot spin up a traditional VM that fast. It just won't come up that quickly. It's got to bring up the operating system. You got to wait for the operating system to boot, and then you got to wait for the services to come up, and then finally you get the environment up that's running that you intended. So the Raspberry Pi, those can create appliances that run on Raspberry Pi as well. So the Raspberry Pi has an image that allows you to create applications that will run in that environment. It does support Raspberry Pi 3. Mirage, together with, there's a number of them, Ermin and Signpost, those are being used to form a core piece of what's called Kinenote or MISO. And those are tool sets for the Internet of Things devices. The security issues as far as what Mirage and the MirageOS team are doing, it's very similar to Debian and Zen itself, as they are totally open. And if there are security issues, they disclose it. They do have a secured issue tracker that you can go to the website. There is an email address that you can use if you run into a suspected security problem and you want to be able to inform them. You obviously you don't want to put those in a public server, right? What about other unikernels? Are there others? Yeah, there are. So I know now they give 3 on their site, but only 2 of them are active. The last one, the guest VM, seems to go off into an unsecured site. So I wouldn't advise going to the link on the third one, the Java guest VM. But the Haskell HAL VM is there, and the Erlang on Zen, that's there as well, which are also unikernels. The other thing is, what about applications that are in production today? Who uses them? That are using unikernels to build them. So Cubes' firewall is a unikernel built using MirageOS. There's also Canopy. There's also UniPy, Pastebin, TLS Tunnel, and CalDAV. There's a couple of other ones here, like OpenVPN, believe it or not, DHCP, and then Let's Encrypt provisioning also use unikernel. So this is not something that is like an academic setting where we're just playing around and experimenting with it. It is actually being used for real work. OS requirements. So Linux, they say Ubuntu 16.04 or higher. Now just remember that if you're installing the desktop of Ubuntu, KVM is not enabled. So you may have to go install the server version in order to get that. Debian 11 or higher, and Debian does enable the KVM on their version of the kernel, even for the desktop. So that's how I was able to actually do something with it. I did try Ubuntu first, and I ran into that KVM problem. I was like, oh, well, I was going to have to install a server, and I thought, well, I don't really want to do that. So I'll just go back over and use my Debian platform to do this. macOS 10.10 plus or higher, FreeBSD 11 plus or higher. So you can install the CAML and OPAM, and that's what we're going to do today. You'll need OPAM 2.1 or later. So if you are installing this from packages, make sure that it is 2.1 or higher. And then OCaml, you'll need 412.1 or higher in order to do the demos that are in here. So then you'll need to install the MirageOS software. There are backends for Unix and macOS, of course. You can run it directly on those platforms. You can run it on Zen or Cubes. There's Solo 5, that supports HVT, and I'll show you that running today. Let's get started. Let's go do an install. Okay, so we're going to set up our environment first by getting OPAM installed. Now, I could install this from a package, and that might work, but there are some specific requirements that I have to have for MirageOS. So I don't want to really take the chance. I want to get the latest and greatest versions of not only OPAM, but also of the OCaml compiler as well. Yeah, we're going to do that. Let me just take a look, and let's see what the packages are. Let me see what we got for OPAM here. OPAM is 2.0, and they should tell you, yeah, OPAM 2.1 and OCaml 4.12, and yeah, we're way below that. So I don't want that version of OPAM. That may cause problems for us. So what I'm going to do instead, now I don't recommend that you just copy and paste. Oh, I need curl. So let me do that. Might as well get that, otherwise we'll be stuck again. So, all right, let's, you'll need Build Essential in order to, if you're, this is on Debian 11. I think it's 11.5 is the current release that I'm running. And yeah, we can, let's just make sure we're up to date before we go any further with this. Yeah, we are. So let's go ahead. Now, the reason why I say I don't recommend doing it this way is because you want to check and see what that shell is doing. I use Liquid Soap, which is a radio software that allows me to broadcast over my local network here, music. So that is written in OCaml, and so I use the OPAM environment all the time. So I'm familiar with that. I've looked at it before. I'm not too worried about it. So we'll get, yeah, see, it's 213. So that's good. It's just asking me where to put it. User local bin's fine. Okay, so we're good to go. The next thing we want to do is we can go back to the page here on the OPAM installation, and we can look at usage. And we can see right away that the first thing we need to do to get started is run the init command, and that sets up our environment for OPAM. OPAM is a package manager. It's called OCaml package manager, and we'll go ahead and do the init. And hopefully, if I have all my prerequisites, the GCC compiler, make, and get and curl, as long as I have those, it will tell me if this errors out. It'll tell me if I have a problem. So I want to modify my dash bash RC. Yeah, we'll go ahead and put that in there. Now it's going to start with 405, but it should switch to the latest, and it did, 414. So hopefully that will become my default compiler, and we'll be all set, because that 405 isn't going to work. It's too old of a release. You have different environments in OPAM. You can set up builds that are using 4.12. You can set up some that are using the latest, which is the release candidate 5 right now. You can set that up too. So you can do experiments with it, and you can switch between those environments on the fly. All you do is you use the opam switch command, and it will allow you to change from one to another. I'll show you that when this is done. But we just got to wait to get through the compile, and I'll be back when this is done. This will take a while. Okay, we're all done. And you'll notice here that it's given me an eval statement here to put it in default. So I'm gonna go ahead and add this to my current environment so that we make sure that we're good. And I'll show you the opam switch list. I can first look and see what is my default. It's 414. That's good. We want that. You can also, there's help for it, and it brings up the man page, which is really nice because these man pages are not located with the Linux ones. They're inside of a .opam directory, so all of your builds are kept separate. So anyway, the next step that we want to do here is we want to go back to our installation instructions and just come down and look for Debian. Now there's the ARM stuff here. Probably went by it. There it is. So the next thing we want to do here is install Mirage. So we'll go ahead and do that. This will also take a while. I think there's I'm not going to hesitate to guess. There's a lot of packages in this. 38. All right, so I'm going to go ahead and we'll pause here, and I'll be back when this is done. Okay, we're all done, and there was 114 packages that were installed. You can always list your packages using the opam list command, and it will show you the versions and then the description of what those packages do. So the next thing I want to do is I want to validate that, yes, it did get installed, and it is 4.3.1. The current version, I think, is 4.4. So not quite sure why we didn't get the latest, but that's okay. That version will work fine for us today. They are in the middle of making a transition over to Dune from Mirage, so it's probably good that we are on 4.3.1, that we don't have to worry about that transition. So, all right, let's do a Mirage help and see what we get. So I get a man page. It is executing properly. It is finding its build environment. So I think we're good, but the only way to really test it is to actually do a build. And so let's go back and do one. And we can go to the hello Mirage. And the first thing we need to do is we need to clone the GitHub that has the skeletal code in it. And in that skeletal code, you'll find a bunch of tutorials. So we need that for today because, yeah, I am not an expert in using this yet. So I'm learning right along with you. Probably 2 pages ahead of you. That's about it. So I'm going to go over here to the tutorial page, and you'll notice a number of them are in here. There's one called app info, hello key, LWT, no app factor. So they recommend that we try the no app first, and that's probably good because this will allow us to look at the two files that are included in the directory. So you need these two files in order to build your Unikernel. The first one is config.ml. This contains your configuration as to what is the name of the file that contains your Unikernel code, and that is Unikernel. And it also shows that we're gonna insert the Mirage base code, which has all of the skeleton code that we need for the operating system interface to either Linux or over to Mac OS or over to Zen or Cubes or whatever. So yeah, that puts in that information, so we have the hooks there that we can use. The other one is main. That's just calling the main function inside of Mirage to start with. And then Mirage will then branch to the Unikernel code. And that code is right there in unikernel.ml. And right now it doesn't do much. It just starts it just starts up and then it returns and exits. So yeah, there's no code in here to really speak of, but that's okay. It'll allow us to text out the build. So let's go ahead and we'll do a configure. And we'll target Unix. That's what the -T stands for. So I need to do a make depends first. I don't have all the files built yet, so let's go ahead and do that. Let's not get ahead of ourselves. That was pretty easy. Don't worry, I'm not going to cover up my mistakes because you'll probably make the same ones and then you'll know how to get out of it. So now I can do my make build because now my Unix stuff is here. And now I'll have my binaries generated once this completes. So OCaml is not interpreted. It generates machine code. So it is a functional programming language, and the code gets dumped into the directory dist for distribution. So right now I should be able to just run. And nothing happens, but we can check what the return code is, and it's a 0, which means it ran and it finished. So we know that, and it finished with a good result, even though it didn't actually do anything. So let's try something a little bit more meaningful now that we know that our build environment is working. Let's go over here to hello, and we'll take a look at the config here first. So you'll notice that there's a couple of things. Again, this is the same, and we're assigning main. We have some packages though that like duration, and we're looking for Unikernel, and this is the name of the output. Hello will be the name of the output file. This job is where you assign devices, and this is assigning the timer code, because we do have we'll get to the Unikernel, you'll see that there is a timer block that it's waiting a certain amount of time for it to expire before it goes to the next step. So then it branches and executes, and then it comes out off to main and looks for a file called hello, and then we should be off to the races. So let's look at the code. So in the code here, this is the same. We are opening except lwt.infix. I'm not quite sure what that means, but hey, I'm learning too. So we have a module hello, and in there we have a time structure, and we have a loop right here, and it's going to loop through. It's going to print this. This is log info, which is going to go to the console. It's going to print the word hello. It's going to sleep for a second and repeat the loop, and it gets incremented until it reaches a count of 4, and then it will exit. So hopefully that is exactly what will happen. So let's try. Let's do the make depends this time. It'll probably work a lot better. If there are anything that it needs, it will go ahead and download those. It'll use opam to get it. So if it needs additional packages, it will automatically get those, which is nice. We should be able to run this. And in distribution, I have a hello. So if I run it, I should get 4 lines with hello on them, and then it should exit. 1, 2, 3, 4, gone. Yep, there we are. And we can check the result, and it's a 0, which means we had a good run. So what if okay, so that's how I tag this for Linux. But what if I want to build this for a different environment? What if I want to build this for KVM? So let me just see if I have a device KVM built first before we begin. We do. It's owned by root. Got to change that. Unless I want to run this package as root, and I don't. Okay, so let's check that again, make sure it's owned by me, and I can open it. Yes, okay. Now, of course, now when I reboot, it's going to change it back to root, but that's all right. So in this case, I want to do a Mirage. I want to do a configure, and instead of doing it to Unix, I'm going to do it to a hypervisor. This hypervisor will be KVM, but it requires a runtime, and we'll get to that. And you'll see that when it starts to do the make depends, it's going to fire off a download, hopefully, in a second here. There, it's gonna see it's looking for Solo 5, and Solo 5 is, and this should construct a totally new executable. And I'll once this is done, this is going to take a while. So we had a make depends build successfully. So now we'll do the make build. Or I should say I had a make depends work, and now we need to actually bind this all together. You can see that it's binding Mirage Solo 5 to my code, my Unikernel. So, but what is it? It's this one, the hello.hvt. So I have to run this as Solo 5 HVT, and then I can put in that, and it should fire up the KVM and start executing the code. You notice that started up pretty fast. It is, both of them are very quick, whether I'm loading this up under Linux or I'm loading this up under an HVT. Now, I could target this for Zen if I had a Zen environment installed. Those, of course, Zen is I think they're still primary on Amazon. So if you want to deploy this to an Amazon cloud, you can, as well as I think Rackspace is also Zen. And I think there's some other mechanisms that you have for other ones too, but we've built it on both sides and it works. So I'm not going to go any further, but there's a lot more examples in here that you can go through on your own. I'm just trying to show you how to set up and build the environment. If you're having problems along the way, check your versions, make sure you have all of the necessary prerequisites. So you need a build essential environment, which has your GCC compiler and your make utility, but you also need curl in order to be able to install opam for the first time. And then you will need Git and to be able to bring down this tutorial. I will show you a couple other things though. It's more than just a bunch of trivial examples. So in device usage, you have a number of devices like block and clock and console, and there's a file system example here that you can look at that are pre-made. They even have published their website. Their website runs as a Unikernel. So in the Git repository for Mirage OS, you will find their website as a member of that Git repository. So if you want to play around with a real world example, you can. Or you want to start with that and then customize it and make it your own. The other one is there's some applications here that have like crypto and DHCP, DNS, and Git, HTTP, and so forth. Also a static website, TLS. That's a small example, of course, of what their full website would have. If you want to learn more about how OCaml works, on their website they have some basic instruction, like a getting started guide that'll get you up on your first project, and then they have some exercises which are kind of esoteric, they're kind of typical computer science kind of exercises, and then a language manual. But if you really want to learn the language deeply, there is a professor that's out here on YouTube. I don't recall his name offhand, but we'll find him. There he is. Michael Ryan Clarkson. And he has his full college course on OCaml here, and it is quite extensive. But they're short videos. They're not, they're not 1 hour each. So he goes through the proper way of doing coding with OCaml, which I think once you augment this with what Mirage is doing and you get a better understanding of the language, I think that would help you understand better how to put things together. So that's where I'm going to leave it right here. Let's go back and talk about some conclusions. So we've gone through the install, and we built a couple of applications and deployed them. The same application, deployed it to Unix and to a hypervisor environment, and also kind of looked around a little bit at some of the other tutorials. There's devices and applications there. Also on their GitHub, there's also space there for you to look at, including even versions of their own website. If you want to start with a working model, you can. So that's all I had for today. If you like this video, please like and subscribe. Hope to see you all again real soon. Bye for now.